Hey everyone, this is Guru. I'm one of the co-contributors of the Waku project, and I do developer relations for Waku. So, starting with the problem statement, Web 2 communications do not preserve your privacy out of the box. So, this is something that exists in all forms of Web 2 communication, whether you use sockets or anything that involves HTTP endpoints. So, your interactions online can be eavesdropped by multiple centralized applications, and your social graph and your private metadata can be exploited by these centralized gatekeepers. So your messages that you send on Web2 are mostly linked with your IP addresses, and your IP addresses can reveal a lot more information than you actually think. So basically, it can reveal the sender and the receiver, and also information like location of the sender and receiver. And along with this, a lot of private metadata, which can be for application-specific processing. And this information can facilitate large-scale censorship or surveillance attacks around the world. It can also hinder freedom of speech. And this is not a problem that exists just with chat, but pretty much with all the Web2 applications that can be in gaming, marketplaces, location sharing apps, or anything that involves machine-to-machine or machine-to-human communication. So to solve this, we've been building Waku. Waku is a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging for your Web3 apps. So we've stick on to 6 main ethos. The first one being censorship resistance and privacy. And we also have modularity by design, which means that you can use Waku with any blockchain of your choice, or it's not even a blockchain. Waku is something that can complement a blockchain. Waku is also adaptive. We have different implementations for different resource-restricted environments. And it's securely scalable, meaning that we don't compromise on the level of decentralization for scaling. And most importantly, I think personally my favorite of all these ethos is DOS protection. A lot of Web3 networks that exist right now are not DOS protected. And even if they are DOS protected or rate limited, they use centralized methods to do it. But at Waku, we've integrated RLN, rate limiting nullifiers, which make sure that we have a privacy-first approach for rate limiting. We'll be talking about it in detail in the upcoming slides. But moving ahead, these are some of the misconceptions that we usually have. Waku is not a blockchain. Waku is not just a chat messaging protocol, but Waku is a generalized communication protocol that you can use for sending any kind of data between nodes. It's more on the network level, built on top of UDP and TCP. So you can pretty much send any kind of data less than 1 MB. And you can use Waku in multiple use cases, revolving around gaming, marketplaces, state channels, and again, anything revolving around communications, which can be machine-to-machine, machine-to-human, or human-to-machine. So talking about the history of Waku, it all started in 2013 when the Ethereum white paper was released. We had the holy trinity of decentralized web, which was Ethereum for consensus, Swarm for storage, and Whisper for communications. But over the years, as a developer community, we've forgot to focus more on other things like Swarm and Whisper. And there's this misconception that blockchains are Web3 and there's peer-to-peer technologies and a lot of other technologies which also contribute to the Web3 vision or the Ethereum vision. Until 2020, there was not much of teams working on Whisper as a protocol for R&D. But in 2020, Waku V1 replaced Whisper in the status app. Waku is an iteration of Whisper. We had a lot of architectural changes happen in the course of time. And in 2020, Status is a messaging app which migrated from Whisper to Waku. Today, we are trying to evolve as the standard for Web3 communications. We are trying to be as unopinionated as possible, and we are trying to build for the open source communities around in Web3. So we also had a mention in Vitalik's blog in December last year. Vitalik mentioned that Waku Whisper still exists as Waku, and it contributes to the deeper vision of peer-to-peer communication, which can complement something like Ethereum. So this was one of the diagrams framed by Gavin Woods, where Ethereum smart contracts are for consensus, Swarm for content address storage, and Whisper for dynamic communications. So dynamic communications should be gas-free, and that's the same ethos that we are trying to stick at Waku as well. Waku does not have any consensus as a network, so it's open for anyone to push and subscribe to messages from a particular namespace. So going ahead, Waku in a nutshell has two main components. The first one is the Waku protocols, which are a family of protocols, and the Waku network, which is an opinionated network that we've built at Waku. So talking about the distinction of nodes at Waku, we have two types of nodes: light nodes for resource-restricted environments like your mobile phones, mobile apps, or browser apps. And we also have relay nodes, which usually run in resource-rich environments like clusters or VPS servers. So based on the category of the node, we have different protocols to cater each of these categories. The first one being light protocols, which can work in resource-restricted environments, and relay protocols for the resource-rich environments, respectively. So this is a diagram which can visualize the adaptability. Waku can work in something as resource-rich like a cluster, VPS, or home server with relay protocols, and with lighter protocols, you can use it on phones and browsers in less bandwidth environments. So today I'll be covering mostly the light protocols. We have detailed documentation about relay protocols in our developer documentation. And we also have RFCs and research articles for each of these protocols. But light protocols are the ones that are mostly used in consumer apps or in hackathons. So talking about light protocols, we have light push, filter, and store. And each of these protocols have a different purpose. But if you want to send a message data into a content topic, you'll be using light push for this. Light push basically pushes a blob of data into a content topic. And we use filter for retrieving or subscribing messages from a content topic. And content topics are nothing but namespaces that exist within the Waku network. And store is a complementary protocol that we have for providing temporary storage for your messages that you send on the network. And also, to talk a bit more on store, we don't have any guarantees or assurance with store protocol as of now, because Waku focuses more on the transport side of things. But for long-term storage, we definitely recommend you to use something like IPFS, Filecoin, or Codex for long-term storage. And it's important to have perpetual storage because at Waku store protocol, the content of the store protocol usually gets cleared out every 30 days. So it's more for temporary storage. And going ahead, looking at the content topic architecture, the whole Waku network is divided into content topics. We have different namespaces, like over here we have topic A, topic B, and topic C, which are 3 different content topics. And there can be multiple nodes listening to different content topics and sending messages to different content topics. And all these content topics are public by nature, just like Ethereum. So anyone can send a message into any content topic and subscribe messages from any content topic. So for any kind of access control, it should be cryptographic. You can use something like LID protocol or something like threshold for doing this before you send data into the content topic. So it's important to set up encoders and decoders to make sure that no one else uses the same content topic as you do. We also have, for simple use cases, we have encoders and decoders within our SDK, but for more deeper and wider use cases, we definitely recommend you to check out other access controls. But the way in which we declare a content topic is based on this particular template. It starts with the application name followed by the version of the application, followed by the content topic name or the category, finally ending with the encoding type. An example for this would be supercrypto, which could be a name for your application. Version could be 1, and notification can be the category of messages that you communicate with this content topic. And you can also have proto as the encoding. So we use protobuf for encoding and decoding in our documentation. So based on the encoding standard that you use, you can change it accordingly. We also have a structure for each and every data packet that is getting sent into the Waku network. So we have different terminologies right now. Some people call these data packets as messages. Mostly developers refer this to be messages, but semi-technical people misunderstand messages to be just chat messages. So messages here means that anything that gets sent from one node to the other is, that's what we call messages over here. And the maximum limit, as I mentioned before, is like 1000 KB. So we have the content topic as the first attribute that goes in. The content topic is used for content-based filtering, and you should be filling the content topic into which you want to push the message, followed by payload, which basically contains the message data. And we also have a meta attribute for application-specific processing, followed by timestamp, which has the time of the message when it was sent. And finally, we have an ephemeral property, which can be a Boolean property. Here, Waku is not ephemeral by default, which means that the messages that you send into the network are evaporatable. So it's not getting stored in the network. So if you want to use store protocol, you should be setting ephemeral to true so that the message stays on the network for 30 days. Anyone can contribute to the Waku network by running your own node. And we have a Docker compose command if you're interested to try running a Waku node. There's no incentivization for running a Waku node yet. Incentivization is currently work in progress. So yeah, this is the simplest way to run a Waku node. And we also have technical research specifications in this RFC. It's available on rfc.wac.dev, which is our request for comments in a collection of all the RFCs that we've had for the protocol. So another important thing that we consider at Waku is vendor lock-in. So there are a lot of Web3 protocols or products which still have vendor lock-in, which means that once you start using the protocol, you cannot migrate it to a different one, or you cannot self-host it in a later stage. So making sure that Waku doesn't have a vendor lock-in was very important in a lot of decision making. So Waku is privacy first by design. And we have two ways of using Waku. The first one is running your own fleet of Waku nodes or running your own network. Or the second way is using the Waku network, which is a network that we've federated for developers or for projects to readily use Waku without having to do much of federation things. So when you run your own custom network, it's still privacy by design. And even in the Waku network, it's privacy by design. We don't have any architectural changes. And all of the code for running a node is available on GitHub. It's open source. And both running a custom network and the Waku network can provide you modularity and adaptiveness. The only differences or the only advantages that you have with the Waku network is it's batteries ready, which means you don't have to federate. You can just use the Waku network along with the SDK to send and receive messages without much setup. And it's also rate limited by default. Not by default, but you can choose to opt out of it, I believe. But then rate limiting is a very novel feature that we've introduced with the Waku network. So no one can send like 1,000 messages in a minute to put Waku network down. So rate limiting exists in Waku. And we also have node operator incentivization work in progress with the Waku network. With the custom network, you don't have to have a incentivization for your node operators. A lot of partners that are using Waku right now have an in-house fleet of Waku nodes running, and they don't have any kind of incentivization for it, obviously. But if you use the Waku network, you can expect incentivization to be there for node operators down the road. But we are actively researching on it. It's work in progress. Also, the only closest technology that can be compared with Waku in the Web3 space is libp2p, at least for me personally, because we have communication protocols like XMTP and a lot of other protocols which are actually built on top of Waku. So XMTP uses Waku nodes behind the hood. So I think the only low-level protocol that exists in the Web3 space is going to be libp2p. And the relationship between Waku and libp2p is both of them use gossip sub, and Waku is built on top of libp2p. It's a service network built on top of libp2p. And gossip sub is the mechanism in which Ethereum nodes talk to each other. So Waku enables discovery in a decentralized and privacy-preserving manner. And by default, libp2p does not preserve your privacy. Your IP addresses are getting exposed when you use libp2p. So these are some of the modifications that we've architecturally implemented in Waku. And with light clients, libp2p has JS Waku, which is the TypeScript implementation of libp2p. And in Waku, we have JS Waku, which is pretty much solving the same problems. And we also have protocol muxing, working, a compatibility to work offline, and native roaming, and all of these features in both libp2p and Waku. But apart from these features, Waku also provides you some upper hands, like Waku is a service network. It's also a turnkey solution. And we implement economic spam protection or DOS protection, like I mentioned before. So these are the advantages of using Waku directly rather than using something like libp2p, which complicates a lot of your development process. Talking about RLN, RLN stands for rate limiting nullifiers. It's a technology that was collaboratively built with privacy scaling explorations in the Ethereum Foundation. So we had a lot of researchers from VAC, which is our research unit, work with PSC team for shipping out this. And Waku is one of the first few projects who is trying to implement RLN on a production level. So we have two segments in decentralized rate limiting process. The first one is a membership contract, which has a membership set deployed on the smart contracts. You can deploy this membership contract on any blockchain of your choice, but right now it's available on testnets. And yeah, this membership contract interacts with the zero knowledge proof that is attached with every message that you send into Waku. So this is how we implement RLN. So every time you try to spam the network, or every time you cross your rate limiting, the network basically doxes you. So you get punished if you cross your rate limits. That's how the whole concept of RLN is implemented in Waku. I also have a quick simulation of how fast a Waku message can be sent. It starts from Singapore, goes to India, now to San Francisco, and to New York, and finally back to Frankfurt. All this happens in like 20 milliseconds, and it's simulated with a real-time size of 2 KB data with real-time machines. So this is how performant and competitive we are trying to be when compared to Web 2 communication protocols. And we also have a couple of resources. The first one that I want to highlight is the developer documentation. It's available at docs.waku.org. And we also have a list of ideas that can be built on top of Waku. They are community curated ideas, and you can find them out at ideas.waku.org. And finally, you can find all the presentations, videos from all the presentations that we've done in the last couple of months. And we had like around 90 projects submitted at different hackathons for our bounties. So all these projects are visible at Awesome Waku repository in our GitHub. So these are the three main resources that can be useful in exploring more about Waku. I also want to highlight a few of the projects that use Waku, some of the projects from hackathons that were around the world. So the first one is Block IoT. The project implements an IoT system that can communicate using Waku protocols. So if you want to make a home automation system, but you don't want a centralized entity to know about your electricity usage or any kind of metric, you can use Waku for this. And you can also connect different IoT devices for this. So this was one of the most exciting projects we've had. And we also had Becamos, which was one of my personal favorites. It was from ETH Rome last year, and it basically implements a privacy-preserving wallet-to-wallet location sharing. So right now with the location sharing options available in iOS or Android, the location is obviously shared with decentralized entities like Apple location services or Google location services. So this particular application enables you to share the locations peer-to-peer with the wallet of your choice. So it was really sleek, and the application was pretty much production ready. So this was one of my favorites. And we also had a couple of games built on top of Waku. We had a multiplayer, a trump card game built with Waku where you can collect cards and also battle with other people. So you can also build fun things with Waku. And one of the recent buzz around the AI, a convergence of AI and blockchain is data privacy. Right now, when you use centralized LLM platforms, all the LLM platforms collect your data, and they need to do it because they use it for recursive training in a later point of time. But um, it makes no sense for them to collect your identity coupled with the data. So that's where Waku can be a middleware, making sure that the prompts that you send to any LLM platform get decoupled from the identity. So right now, the platforms can find out what you're searching for on these platforms, and they can advertise you based on what you're searching for. And we also had a recent buzz that most of the data from ChatGPT was traded with another centralized entity for just in the name of machine learning, which doesn't make sense because people obviously search a lot of critical things in these LLM platforms without understanding this big risk. So this is where Waku can come as a middleware, and you send your prompt to Waku, and there's a filter node running on the other side, which basically takes in the prompt and processes the prompt. So Waku can be a good fit in compute marketplaces, in LLM platforms, and in the whole sector of machine learning. Yep, so if you want to learn more about Waku, if you want to see some code snippets, you can find them at docs.waku.org. We also have some example apps set up for you to try out. It's available at examples.waku.org. And please feel free to join our Discord where we post our announcements every week. We also make sure to be as open as possible. We have around 17 co-contributors working for the Waku team, and we post out our weekly updates over here and also on our Twitter. So make sure to follow us over there. And we also have a Next.js boilerplate for anyone who's trying to build on top of Waku. I know there's a lot of pro-privacy hackathons coming up in the next couple of weeks. There's ETH Berlin followed by ETH Prague. So all of these hackathons have privacy as the core angle. So if you want to experiment with Waku, make sure to check out the Next.js boilerplate, which has less than 100 lines of code, but has a complete implementation of Waku. I can also run through the code real quick and show you how the code should actually look like. So we are also actively working on refactoring our SDK. So we'll be having a new SDK in a couple of months or a couple of weeks, depending on the development that we're having. But yeah, right now we have an SDK available for JavaScript, and it's very simple. You'll just have to install Waku directly from our documentation. And then once you do that, you can import the dependencies, which are listed here. Create light node for creating a light node instance, and wait for remote peers is for peer discovery. And we also have encoders and decoders within our SDK, where we have create encoder for the encoder and create decoder for creating a decoder. And as I mentioned before, we use protobuf as the encryption and decryption standard for most of our documentation at least. So we also installed the particular package, protobuf.js for JavaScript. And after that, it's pretty much simple. You just declare a content topic. The content topic should follow the naming convention that we discussed before. And after that, you create a message object. Over here, I have a chat message object, which has a timestamp and a data. So this is how you template a data object that gets sent into Waku. And once that is done, you can have a function for sending data, which will be coming back again after we set up the node. But before that, we have a use effect hook, which sets up a node by using the create light node command. And in the create light node command, you can pass this specific thing called default bootstrap. You can set it to true if you want to use our default bootstrap nodes. We set up a bootstrap nodes to make it easier for developers to build at hackathons or just to experiment with Waku. So you can set it to true if you're trying to experiment, or you can also set a particular set of fleets as the bootstrap nodes, alternatively. But going ahead, you just start the node by node.start, and that should get your node started. And after the node is created, that's when you have peer discovery. So for this, we have a function called wait for remote peer. This function basically waits for other peers to connect to your Waku node. So the way it works is light nodes get connected to another relay node, and these relay node carry out most of the resource consumption or resource operations that require a lot of resources. So once the remote peers are connected, you can go ahead and create your encoders and decoders. For this, you can just define an encoder using the create encoder function. Inside the create encoder function, you can have the content topic into which the message should be pushed. And you can also set the ephemeral to be true or false over here. So if you need to store the message, just set it to true. And after that, you can set encoders. And then similarly for decoders, you just use the create decoder function to pass in the content topic. And then your decoder should be set up successfully. And you also need a callback for retrieving all the messages from your filter nodes. So it's pretty much simple. You have all the code snippets available on our documentation. You can get the payloads in different formats, and you can find more in-depth explanation about this in the docs. And the way in which the filter nodes work is based on subscription. Waku follows a pub-sub architecture, which means that you subscribe to a particular content topic and you keep receiving messages from the content topic. So that's pretty much it. I think the only part that we missed is sending the data. So for sending data, you just have to create the message object just like we mentioned before, and then serialize the message using the encoder that we just created. And finally, you can use lightpush.send function for pushing the message into the content topic. You'll just have to pass in the encoder and the payload into this function, and it gets your message into the content topic. So if the ephemeral is false, the messages getting transmitted are real time, which means that you cannot expect the message to be saved in the network for a particular amount of time. So yeah, that's all about sending, receiving, and storing messages with Waku. And this boilerplate is available on GitHub in the link that I shared before. And it also has a very simple UI that explains you step by step about the processes that are happening behind sending and receiving a message. And this can be the most minimal example that you can try. And we also have other applications like Waku, which was developed by one of our core contributors in our Waku team. This is basically an application where you can host question and answers. So you can just share the link with other people, and they'll be able to ask questions through this link, and it'll pop up for me over here. And I also believe polling is available, or it's going to be available really soon with Waku. So we are trying to build all these experimental stuff. We have a couple of open bounties for developers to earn a couple of maybe $1,000 or $2,000 for doing all these examples. So you can find more about Waku bounties at bounties.waku.org. We are just trying to implement Waku in more of non-chat use cases, because there are quite a lot of chat applications that use Waku. So we are trying to explore non-chat use cases. But when we talk about the enterprise integrations with Waku, Waku is being used by projects like XMTP, also the Graph. The Graph uses Waku in a very novel way in which they try to decentralize the indexers by a pub-sub communication. So Graph, and we also have Railgun, which is a privacy-focused layer 2 on top of Ethereum. So Railgun also got a mention from Vitalik in the last couple of weeks. So they've been buzzing in the Web3 space for quite a while, and they are using Waku as well. So there are a couple of projects that use Waku in the production, but we also acknowledge that there are a lot of issues with the SDK because of the rapid changes that we are doing and a lot of features getting delivered. So feel free to join the Waku Discord, and if you have any questions or if you need any support, the co-contributors are always available to help. So that's all from me for today. But if there are any more questions, I'll be happy to take a few questions.
Hi, thank you very much for the talk. Could you elaborate on the censorship resistance? For example, I saw that you had to connect to bootstrap nodes at the beginning, and the network packets could still be monitored and blocked by an ISP. Is there some workarounds around it?
Yeah, so censorship resistance over here is in a way that we don't need the identity for a message to be published or subscribed. So let's say there are two actors in the node, Bob and Alice. So if Bob sends a message into a namespace or a content topic, Bob will be sending it inside the namespace, and he doesn't necessarily have to, provide any wallet address or any kind of identity to support this message. So the IP address is also not included as a part of the message. And the other end, where Alice or other subscribers are subscribing to the particular namespace, will not know the message is from Alice, is from Bob. So that's how we decouple the identity of the sender and receiver by using namespaces. And with libp2p, it's you can definitely find out the IP address of the peer who you are connected to. But with Waku, that's where we are having a novelty where you can't find the IP address of the connected peer.
You talked about chat applications, but for example, let's say you wanted to build something like Farcaster, decentralized Twitter. Could you describe how that would work? Like, I understand there's a storage solution for it, or?
Yeah, so for Farcaster, I assume there is a need for storage, definitely, because once it's something like Snapchat. Once you send a message and once it's delivered to the other peer, the message is not stored on any specific database or any specific storage. That's how Waku naturally is. For proof of concept for something like Farcaster, you can definitely use Store protocol, but we also want to be transparent that Store is currently centralized. But we also have other solutions like Codex, which is a content address storage like IPFS or even IPFS. They can be the right fits for these use cases. So you store these messages on IPFS, or if a user wants to send an image over Waku which exceeds 1 MB, they can store it on IPFS, and the CID gets transmitted on Waku. It's not the whole file getting transmitted on Waku. So this is how we are trying to solve messaging use cases, and Status has been already doing it for the last couple of years. But for Farcaster, definitely, they can readily implement Waku, and it can solve a lot of privacy issues that exist in social media applications in Web 2.
Thanks for the talk. With respect to RLN, is the rate limit configurable? And if it is, how is it configured? Who gets to set the rate limit?
Right. So right now, RLN is still experimental in our stack, but we've been getting a lot of good feedback from different teams who are trying to dogfood it. But for the network, we have a rate limit. For at least the Waku network, we have a rate limit of 1 message per second, which is just for the current timing. But then RLN depends on the reputation system that you create for a particular identity or a particular peer. That way, you don't essentially get to spam the network with like 1,000 messages a second, and you get blacklisted and your IP or your identity gets doxed once you cross the limit. So RLN, there's a smart contract deployed on the blockchain, which basically has the membership set of all the peers or all the memberships generated from the contract. So this is the only segment where Waku has a blockchain part of it. Apart from this, Waku is more of a privacy tech protocol than a Web3 protocol. But right now for the Waku network, we have 1 message per second as the limit, which is totally customizable depending on the shared resource that you have in your set of bootstrap fleets. Yeah, so feel free to reach out to me if you have, I can take a few more questions.
Thank you so much for the presentation. First, I have a question around. You mentioned that the graph is using Waku. Is it using it like a Kafka cluster, like following like a PubSub architecture? If it's using it like that, those are many calls, and they will definitely hit the rate limit. How are they handling that?
Yeah, so right now, all the integrations that we have currently don't implement RLN. RLN is something that we've implemented only in the Waku network. But the way Graph uses is, Graph has a separate team called Graph Ops within their organization, I believe. And Graph Ops has GraphCast, which is one of their, exactly where Waku is being used. And also, I believe, Subgraph Radio. So that's where Waku is being implemented. So right now, they have they've just statically declared the rate limits for the time being. They don't implement RLN or any of the decentralized rate limiting as of now. So they have like a static number defined to the number of messages per second, which is not the right way to do it. But the Graph team is also helping out with us in dogfooding RLN. But it'll be in production only after it's battle tested for quite some time. But yeah, that's how Graph is using it.
And I have one follow-up question. And in such enterprise scenarios, there's a lot of data privacy issues and regulation that companies has to follow. When using Waku, the data is just decentralized. The data is anonymized, and there are no regulations there. How does it work?
Yeah, it's very tricky to be solving this particular problem in this space because there are a lot of bad actors as well. Like Waku can also be used for a lot of dark fi use cases or a lot of use cases that cannot stick to the ethical values, I would say. But in terms of privacy, it solves a lot of bigger issues like people who try to use Messenger on a Web2 platform. They are more vulnerable to be every time you send a message on a Web2 platform, the general Web3 public who is not much technical would not know that their message is passing through a lot of servers, a lot of HTTP gateways, and it can be intercepted anywhere at any point of time, even if they are encrypted. So that is the biggest problem that Waku is trying to solve. I'm trying to be more permissionless and more trustless. So there are a lot of bad actors, definitely, but we are trying to address all these problems on a long run. Yeah.
Thank you.
Thank you.
Thanks for the talk. One question. As I understand, the relay nodes are acting as a storage for the messages itself. So the main namespaces, storing the namespaces with a payload. So how do you guys, or how it's in a scenario when a certain set of nodes keep these or this node namespace, they are detached from the network in a case of a censorship, for example. What does it mean to the network in a whole? I mean, is this namespace completely lost? Is the data completely lost, or is it somehow replicated between the nodes?
Yeah. So namespaces are primarily used for content routing. So they are like an address through which the messages go through. And like on a storage perspective, right now the store nodes, the content topics only store the messages if the ephemeral is set to true. But on a long run, if Waku is used with something like, let's say IPFS, that's where you can make it completely ephemeral, where you don't lose the messages. And there's also another problem that we are trying to solve at Waku, that the message delivery is also not guaranteed right now. Like you don't know if a message reached to a particular node if you send it with Waku. But there are many projects that implement novel mechanisms like pinging or sharing a secret to make sure that a message was delivered. So these are all in proof of concept stage. Different enterprises are using different ways to solve this problem. But when we talk about namespaces and the evaporability of evaporatability of storage. I think it's mostly like namespaces are just for content routing rather than content storage. But for solving this issue, I think something like IPFS or Codex is going to be the answer. So we are actively working with these storage protocols to understand the requirements. We've been doing a bunch of things with IPFS, but it's pretty hard to implement storage with IPFS without having to depend on a HTTPS gateway. So if you want to run an IPFS node locally and if you want to pin the file, it's pretty hard. But if you want to do it with a gateway service which depends on HTTPS endpoints, it's possible, but we don't want to depend on a HTTP endpoint for that. So that's the only blocker that we have right now with storage. Yeah. Cool, then I think I'll wrap up the workshop with this. But if you have any more questions, feel free to reach out to me. I'll be happy to take it one-on-one. Yeah. Thank you.